Namaste children. Today we will discuss the continuing part of real numbers. Example 2. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integer. So let solution, let a be a positive, let a be a positive even integer, let a be a positive even integer. So by division algorithm, by division algorithm, by division algorithm, by division algorithm, a is equal to bq plus r, where 0 less than or less than b. So 0 less than or less than b. A is equal to bq plus, so a is equal to bq plus r. A is equal to 2q plus r. Here 0 less than or less than 2. Look at this children. A is equal to bq plus r. Here 0 less than or is equal to or less than b. This implies that r must be 0 or 1. So r must be 0 or 1, but a is a positive even number. This implies that r is equal to 0. Once again, r less than or is equal to, 0 less than or is equal to or less than 2. This implies that r must be 0 or 1. But a is a positive even number, or becomes 0. Therefore, a is equal to 2q plus 0. A is equal to 2q. Therefore, every positive even integer is of the form 2q. Therefore, every positive integer is of the form 2q. So once again, this is first one. Let a be a positive even integer. By division algorithm, a is equal to bq plus r, where 0 less than or is equal to or less than b. So a is equal to 2q plus r. Here 0 less than or is equal to or less than 2. So the conditions must be, or r must be 0 or 1. But here a is a positive even number, so r becomes 0. A is equal to 2q plus 0. A is equal to 2q. Therefore, every positive even integer, once again, every positive even integer is of the form 2q. Second one, so the second one is, so every positive odd number is of the form 2q plus 1. So integer. So once again, let the second one, every positive odd number is of the form 2q plus 1. So second one, let a be a positive odd integer. By division algorithm, a is equal to bq plus or. If 0 is less than or is equal to or less than b. So a is equal to 2q plus or, 0 less than or is equal to or less than 2. So this implies that or is not equal to 0, because or is equal to 0, it must be a very positive even integer. So or is not equal to 0 because or is equal to 1. ನಾವೇನು ಮಾಡ್ತೀವಿ ವಿದ್ಯಾರ್ಥಿಗಳೇ, r is equal to 0 ಆದಾಗ ಮಾತ್ರ ಅದೇನಾಗುತ್ತೆ, ಈವನ್ ಪಾಸಿಟಿವ್ ಇಂಟಿಜರ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು ಆಡ್ ಇಂಟಿಜರ್ ಇಲ್ಲಿ ತಗೋಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು, r ನ ಬೆಲೆ ಯಾವಾಗಲೂ ನಾವು ಏನು ಮಾಡಬೇಕು, 1 ಆಗಿ ತಗೋಬೇಕು. r is not equal to 0 where r is equal to 1. Substituting this, a is equal to 2q plus 1. Therefore every positive odd integer is of the form 2q plus 1. A is equal to 2q plus 1. Therefore every positive odd integer is of the form 2q plus 1. So once again, second, make a be a positive odd integer. By division algorithm, a is equal to bq plus or, where 0 is less than or less than b. A is equal to 2q plus or, 0 less than or is equal to or less than 2. So or is not equal to 0, or becomes 1. So a is equal to 2q plus 1. Every positive odd integer is of the form 2q plus 1. Example 3. So show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is a some integer. So solution, let a and b are be a positive integers and a greater than b. So by division algorithm, a is equal to bq plus or, where 0 less than or is equal to or less than b. So if b is equal to 4, because integer is of the form 4q plus 1 or 4q plus 3, we take 4. So a is equal to 4q plus or, 0 less than or less than b. Therefore the less than 4. So the possibilities of remainders are 0, 1, 2, 3. So we cannot apply 4 because any positive integer a can be divided by another positive integer b. So it leaves the remainder or that is smaller than b. So remainder ಏನಾಗಿರಬೇಕು ಯಾವಾಗಲೂ ಕೂಡ ರಿಮೈಂಡರ್ ಇರತಕ್ಕಂತ ರಿಮೈಂಡರ್ಸ್ ಏನಾಗಿರಬೇಕು ಯಾವಾಗಲೂ smaller than b. ಇದಕ್ಕಿಂತ ಏನಾಗಿರಬೇಕು ಕಮ್ಮಿ ಇರಬೇಕು. ಇಲ್ಲಿ ಎಷ್ಟಿದೆ 4 ಇದೆ. The remainder is smaller than b or less than 4. So r must be 0, 1, 2, 3. So if a first condition, if r is equal to 0, first condition r is equal to 0, a is equal to bq plus r, 4q plus r, a is equal to 4q plus 0. This implies that a is equal to 4q. This implies that a is equal to 2 into 2q. So is divisible by is divisible by 2. Therefore this is a, so 2 into 2q is equal to a is equal to 2 into 2q is divisible by 4. This is an even number. This is the first condition. So we apply second conditions where r is equal to 1. So a is equal to 4q plus r. A is equal to 4q plus 1. So a is equal to 2 into 2q plus 1 is not divisible by 2. So this is an odd number. This is an odd number. So second condition is what? Third condition, r is equal to 1. So r is equal to 1. A is equal to 4q. Sorry, r is equal to 0. R is equal to 1. R is equal to 2. A is equal to 4q plus r. This implies that 4q plus 2. A is equal to 2 into 2q plus 1. So is divisible by 2. So this is an what? Even number. Once again, later we try if r is equal to 3. First, let solution, let a and b are be a positive integer and a greater than b. By division algorithm, a is equal to bq plus r, 0 less than or is equal to or less than b. If b is equal to 4, a is equal to 4q plus r, 0 less than or is equal to or less than 4. 4 ಗಿಂತ ಕಡಿಮೆ ಶೇಷ ಯಾವಾಗ ಬರ್ತವೆ? r is equal to 0, 1, 2, 3. So if conditions r is equal to 0, a is equal to 4q plus c, we write a is equal to 2 into 2q. So e is divisible by 2. This is an even number if condition is 0. So if condition is r is equal to 1, a is equal to 4q plus r, a is equal to 4q plus 1, a is equal to 2 into 2q plus 1 is not divisible by 2. This is an odd number. So if r is equal to 2, a is equal to 4q plus r. This implies that 4q plus 2, a is equal to 2 into 2q plus 1. Again 2 into 2, 4, 2 ones are 2. Is divisible by 2. There is an even number. So next, the fourth conditions. Next, the fourth condition, r is equal to 3. So a is equal to 4q plus r. This implies that 4q plus 3. We apply 4q plus 2 plus 3. So now 3 and a half barkobodu, 2 plus 1 agi baribodu. We write 3 in 2 plus 1. So A is equal to 2 into 2q plus 1 plus 1. So here is 2 2s are 4, 2 1s are 2, 1. So we write 2 into 2q plus 1 is not divisible by 2. Divisible by 2. Therefore, this means 2 into 2q plus 1 plus 1. This is an odd number. Therefore, any positive integer is of the form 4q plus 1 or 4q plus 3. So q is some integer. If conditions 3, a is equal to 2 into 2q plus 1 is not divisible by 2. This is an odd number. So any positive integer is of the form 4q plus 1 or 4q plus 3. Exercise 8.1. So use Euclid's division algorithm to find the HCF of 135 and 225. So first write 135 and 225. Step 1. So we start with the larger integer 225. So 225 is greater than 135. So 225 divided by 135. So 135 225. Divide 225 divided by 135. So 135 ones are 135 is more. 135 ones are 135. 5 minus 5 0. 5 is subtracted in 5. We get 0. So 3 is not subtracted in 2. So go to the next. So here take 12. 3 is subtracted in 12. So 9. So 1 minus 1 0. Dear students, 135 is subtracted in 225. We get remainder 90. So write 225 is equal to 135 into 1 plus 90. So once again 225 is equal to 135 into 1 plus 90. So in step second, so we consider the new divisor and the new remainder. So this is dividend. Dividend is equal to divisor into quotient plus remainder. So in the next step we consider new divisor and the new remainder. So we take remainder and the new divisor. So 91s are 90. So 5 is subtracted in 5, we get 5. So the 9 is subtracted in 30, so 4. So finally 90 is subtracted in 135, we get the answer 45. 45 is the remainder. Dear students, the remainder will be 0? No, the remainder will not be 0. So continue the process up to the remainder is 4. So next 135 is equal to, dividend is equal to divisor into quotient plus remainder 45. So next we take step third. So next we consider the new divisor and the new remainder. So we apply the division algorithm lemma, we get. So illu kuda ಏನು ಮಾಡಬೇಕು, we apply the division algorithm lemma and also illu kuda we apply the division algorithm lemma. So in step second 45 2s are 90. Dear students, the remainder will be 0. Yes, the remainder will be 0. This process cannot proceed at any further. We claim that the HCF of 135 and 225 is at the divisor at this stage. So the divisor at this stage is what? So we write 90 is equal to 45 into 2 plus 0. So 45 into 2 plus 0, the remainder will be 0. So the process will not continue. At this stage of, at this last stage of divisor, ಎಲ್ಲಿ ಲಾಸ್ಟ್ ಸ್ಟೇಜ್ ಅಲ್ಲಿ ಇರತಕ್ಕಂಥ ಡಿವೈಸರ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ಮಾಸ್ HCF ಅಂತ ಕರಿತೀವಿ. ಸೊ ದ HCF ಆಫ್, so the HCF of 135 and 225 is equal. So the divisor at this stage is 45. Therefore, the HCF of 135 and 225 is equal to 45. In exercise 8.1, second problem, show that any positive or integer is of the form rq plus 1 or rq plus 3 or rq plus 5 where q is some integer. Solution: let a be a positive integer, let a be a positive integer and let b is equal to 6. By division algorithm, a is equal to bq plus or, comma 0 less than or is equal to or less than b. If b is equal to 6, a is equal to 6q plus or. So if b is equal to 6q plus or, this implies that, so the remainders are 0, 1, 2 comma 3 comma 4 comma 5. So because the remainder, it leaves the remainder b, that is remainder or that is less smaller than b. So the remainder or will be smaller than b. ಆರಕ್ಕಿಂತ ಏನಾಗಿರಬೇಕು ರಿಮೈಂಡರ್ ಕಡಿಮೆ ಇರಬೇಕು. that is the remainders are 0 comma 1 comma 2 comma 3 comma 4 and 5. So if first condition if r is equal to 0, then a is equal to bq plus r, a is equal to 6q plus 0. So a is equal to 6q. So is divisible by 2. Therefore 6q is even number. So the first condition, if r is equal to 0. Second condition, r is equal to 1. So a is equal to bq plus r, a is equal to 6q plus 1. So is not divisible by 2. Therefore 6q plus 1 is odd number. Once again, so by let a be a positive integer and let b is equal to 6, by division algorithm a is equal to bq plus r, 0 less than or is equal to or less than b, a is equal to 6q plus r. This implies that the remainders are 1, 0, 1, 2, 3, 4, 5. First condition 0, a is equal to 6q. 6q plus 0, a is equal to 6q is divisible by 2. Therefore 6q is even number. So second condition, if r is equal to 1, a is equal to bq plus r, a is equal to 6q plus 1 is now divisible by 2. Therefore 6q plus 1 is odd number. So the third condition, we apply third condition, a is equal to, so r is equal to 2, a is equal to bq plus r, so a is equal to 6q plus 2. This implies that a is equal to 2 into 2q plus 1. So a is equal to 2 into 2q plus 1 is divisible by 2. Therefore 6q plus 2 is what? Even number. 6q plus 2 is even number. So the fourth condition, if r is equal to 3, a is equal to bq plus r, a is equal to 6q plus 3. So is divisible, is not divisible. So is divisible by 2. 6q plus 2 is even number, is not divisible by 2. Is not divisible by 3. Therefore, 6q plus 3 is odd number. Odd number. So, the fourth condition, if r is equal to 4, a is equal to bq plus or a is equal to 6q plus 4. 2 3s are 2 2s are. So, is divisible by 2. Is divisible by 2. Therefore, 6q plus 4 is even number. Once again, repeat. If r is equal to 2, the conditions a is equal to bq plus or a is equal to 6q plus 2, a is equal to 2 into 2q plus 1 is divisible by 2, rq plus 2 is even number. So, if conditions r is equal to 3, a is equal to 6q plus 3 is not divisible by 3, 6q plus 3 is odd number. Fourth conditions r is equal to 4, a is equal to 6q plus 4 is divisible by 2. Therefore, 6q plus 4 is even number. So, dear students, the last conditions is what? S. So, 4, 5, 6. This one is 4, this one is 5th. 1, 2, 3rd, 4th, 5th and 6th. If r is equal to 5, a is equal to bq plus r. A is equal to 6q plus 5 is not divisible by 2. Therefore, 6q plus 5 is odd number. Is odd number. Therefore, once again, therefore, once again, any positive integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. So, the last r is equal to 5 is not divisible by 2. Therefore, 6q plus 5 is odd number. So, any positive integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Dear students, in exercise 8.1, first main first and second is completed, and do remaining all the problems yourself. Thank you.